In this video, we will discuss what is the Doctrine Entity Manager. The Entity Manager, as the name implies, manages entities and their various states. It also gives you access to certain connection methods. Normally, to issue begin transaction, commit, or rollback, you would first have to gain access to the connection itself. However, the Entity Manager will do that for you by calling the appropriate method directly from the connection. The Entity Manager class also provides a static factory method called create. We use create to create an instance of the Entity Manager, which we can then use later on. The Entity Manager also supports a low-level query method called find. Find is based upon the ID field or the primary key. It's a very simple lookup mechanism, but highly effective and very fast. The Entity Manager manages entities by saving them, which is called persist, deleting them, which is called remove, executing locks, and finally flush, which instructs Doctrine to execute all operations currently in the queue. Finally, the Entity Manager also provides support for what's called a proxy. The Entity Manager can change the entity's state. There are several commands which will do this. A managed entity is an entity that has recently been persisted or an entity that has been retrieved using a find operation from the Entity Manager itself or a repository. Refresh refreshes the entity state. Detach takes the entity away from the Entity Manager and allows you to operate upon it independently without fear of accidentally updating or modifying the database. And merge allows you to take a detached entity and merge it back into the Entity Manager's unit of work, and it will then return a managed instance of the entity. A managed instance can then be persisted, updated, removed, etc. Here's an example of a block of code which is used to get an instance of the Entity Manager. The file name is entity.manager.php. First of all, we would add one or more paths to where our entity definitions are located. In this example, they are all off of the current directory under Application Entity. We then create an instance of the annotation driver using an annotation reader instance and the path information. We then specify class exists to make sure that the annotation driver is only working with existing entity definitions. We then use Doctrine ORM tools setup. The true parameter has to do with caching. If set to true, caching is done in memory using arrays. Otherwise, if it's set to false, it will try to use APC, Xcache, Memcache, or Redis caching. We then associate the driver generated on line 12 with the configuration. We pull in our database parameters, and finally create the instance of the Entity Manager using a static call to create. In this example, ORM Entity Manager Detach, we are testing to see what happens when you attempt to update an entity which is no longer managed by the Entity Manager. First of all, if you'll notice on line 16, we get an instance of an entity using the find. The find command requires the name of the entity as an argument, and finally the value of the ID field. This returns an instance of the entity, but furthermore, it's important to note that this instance is what is called managed. We can then modify properties in the entity, as we see on line 21, and on line 23 we persist, and flush instructs Doctrine to actually execute the currently queued operations. On line 26 we deliberately detach the entity. We then make a property change and attempt to persist again. If we run this example, you'll notice that the first update was successful. The second update, however, was not successful, as what Doctrine assumes is that because the entity is no longer managed, it's assumed to be new, and Doctrine tries to insert it into the database, which of course causes an integrity constraint violation. The Entity Manager also has a fairly extensive query support. You can run create query to utilize the Doctrine query language. There's also named query and native query and named native query. And finally, you can also get an instance of the query builder, which allows you to generate a query using an object-oriented approach. In this example, ORM queries dql.php, we generate an SQL statement on lines 16 through 18. On line 19, we use create query from the entity manager to create a Doctrine query language instance. We can then assign the parameter, retrieve the SQL, and also retrieve the result. In this case, you'll notice that the fields are broken out independently. The placeholder is represented with a question mark, and we have a list of all prospects where the last name is Richards. In this example, ORM queries querybuilder.php. It's exactly the same logic as before. However, in this case, we are using the create query builder from the entity manager to get an instance of the Doctrine query builder. On lines 17 through 20, we then generate the same SQL statement, but using an object-oriented approach instead. We can then retrieve the SQL generated and finally directly execute the query by specifying getQuery, getResult. The results then are identical to the previous example. The difference is that we are using an object-oriented approach to SQL instead of direct string manipulation. The Entity Manager also includes a series of classes which are referred to as Hydrators. What the Hydrators do is they allow the Entity Manager to translate between the entity objects and the structure required by the particular operation. So for example, you might need to go object to object, object to array, or an object into individual scalars or variables. We also have single scalar and simple object hydrator. It's worth mentioning what's called the unit of work. This can be obtained by specifying Entity Manager get unit of work. It's created and used internally by the Entity Manager itself. It queues operations and then executes them upon flush. It's responsible for inserts, updates, and deletes, and it also operates on what are called collections. The collections are an array of entities which need to be operated upon all at once. The unit of work also processes lock requests. Another thing that the unit of work does is anything that will be scheduled or will happen upon a certain condition. An example of this would be Cascade Operations. So if you delete a parent and the parent-child relationship is annotated with Cascade equals persist or remove, etc., when the parent is removed, all of the child objects are removed as well. This is done by the unit of work. The unit of work also checks to see if the orphan removal flag is set, and if there is a child entity with no parent, that will be removed. The Entity Manager also handles what are called Lifecycle Events and tracking policies. Lifecycle events occur through the life cycle of the entity, and tracking policies are how the Entity Manager determines if there's a change or not. As mentioned before, there's a method called getUnitOfWork, and you can also determine its size by accessing the size method. Lifecycle events have to do with the life cycle of the entity. The Entity Manager has methods which affect the life of an entity. So for example, persist is used when the entity is first created. Remove is used when the entity is finally removed from the system. Update is used frequently during the life of an entity. The lifecycle events which are then available for implementation include pre and post, which surround the various important methods accessed by the Entity Manager and processed by the unit of work.